Okay, so section 4, we're going to take the information we talked about on binomial probabilities and we're going to extend it a little bit and make it by doing so, it'll allow us to perform some calculations like we did in section 2, but in a much easier manner so that we can put those probabilities to good use. So this section is on the mean, variance, and standard deviation. And you're also going to see us talk about usual and unusual values again. So, first of all, in that section entitled formulas, okay, these are the formulas that we were using in section 2 when we were calculating mean, variance, and standard deviation in all of those discrete probability distributions. And we had to do the columns and we had to do the x times p of x and x squared times p of x, etc., which was kind of a lengthy process. What we're going to be able to do is we can adapt those formulas because of the nature of a binomial distribution, and we can shortcut that. And this is what we're going to use for this section. Okay, the mean is equal to n times p. That's it. N is the number of trials, p is the probability of success. The variance is n times p times q, and then the standard deviation is the square root of that. So again, kind of similar to what we were doing when we were working with the binomial distributions, all I need in these examples is n and p, and I'm good to go. Okay, so we're going to look at some of that. Now, down below, to find usual and unusual, again, we need to find max and min. Here are the formulas, that range rule of thumb for doing maximum and minimum values. The minimum value is the mean minus 2 standard deviations. The maximum value is the mean plus 2 standard deviations. Anything between those min and max would be usual. Anything outside the min or the max would be unusual. Okay? So we're going to put those formulas into play. And they're going to give you several different situations with the problems, but you're going to see that the process as you work these is going to be the same over and over and over again. Okay, so let's start with number 4 on the top of the page there. Okay, it says on the back side here. So number 4 says a Gallup poll of 1,236 adults showed that 14% believe that bad luck follows if your path is crossed by a black cat. Okay, so n equals, and they come right out and tell you what n is and what p is. Okay, n equals 1,236, p equals 0.14. Okay, we're being asked to find what is find the mean and find the standard deviation, and then find the min and max. Okay, so I'm just going to use my calculator and plug in the numbers. So mu equals n times p, which is equal to 1,236 times 0.14. Okay, the product of those, I get 173, sorry. Okay, 173. Okay, now if we use the round off rule like we've talked about, 1 decimal place, okay, it would be a 0.0. You can use it, you don't have to. Now, standard deviation equals the square root of NPQ. So that's the square root of 1,236 times 0.14 times, now I've got N and P, I just need to plug in Q. The thing to remember here is that Q is 1 minus P. Because it's binomial, P and Q have to add to 1. So this would be 0.86. When I multiply those together and then take the square root, I get a standard deviation of 12.2. Okay? So those are the first two things you're looking for. To find the minimum, I'm going to take 173 minus 2 times 12.2. And for the max, I'm going to take 173 plus 2 times 12.2. So I get a minimum value of 148.6. I get a maximum value of 197.4. Okay, and that's all it takes to calculate those problems. Okay, and like I said, they're gonna vary some of the questions a little bit here, but ultimately that is the process for all of these. Find the mean, find the standard deviation, find the range of values. Now, you'll see they're going to ask you some questions. Is it unusual or not? Again, is the possibility between or outside of, okay, the given values? Go down to number 7. Number 7 says, the midterm exam in a nursing course consists of 75 true-false questions. Assume that an unprepared student is going to guess for all of the answers. Okay, find the mean. Well, to find the mean, the number is 75. Since these are true-false questions, my probability of success is 0.5. 50-50. Either I get it right or I don't. Now, that means I get a mean of 37.5. And then plug it into the standard deviation formula. That's the square root of 75 times 0.5 times 0.5 again. Again, P and Q have to add to 1. Typing that into your calculator, I got a standard deviation of 4.3. Now, it said, would it be unusual for a student to pass this exam by guessing and getting at least 45 correct? Okay, so I want to know is if the probability of X is equal to 45, okay, then would we consider that passing? In other words, would we consider that well? Okay, so we're still dealing with the. So in other words, it's got to be, if it's unusual, then it would be above the maximum. Okay, by passing. Failing would be like below the minimum. So what I need to do here then is when I find that maximum value, the maximum is 37.5 plus 2 times 4.3, and I get 46.1. Excuse me. Now, 45 then is not outside of or beyond the 46.1 that's my maximum. Okay, so it's actually between Okay, it's actually between the two values. So would it be unusual? I would have to answer no. Okay, it's only going to be unusual if it is beyond the min or the max that I calculate. Okay, so that's where that range rule of thumb is going to come into play. Okay, one more, and you'll see, like I said, it just repeats itself over and over again. Let's go to the very last page. Number 13, it says an experiment involving gender selection method involves a control group of 15 couples who are not given any treatment intended to influence the genders of their babies. Each of the 15 couples has one child. Okay. First of all, I'm going to let you can cross out part A. We're not going to worry about the table here. So I want, based on that, I want to find the mean and standard deviation for the group. Okay. So N is going to be 15. And P, okay, so we're looking at either boys or girls, so equal chances of both. So multiplying there, okay, 15 times 0.5 means mu is 7.5. Okay, so standard deviation is the square root of 15 times 0.5 times 0.5 again, or I get a value of 1.9. Okay, and it says if the couples have 10 girls and 5 boys, is that result unusual? So in other words, is 10 out 10 out of the 15 of the same sex, is that above the max? So let's look at what the maximum value is. So my maximum value is the mean 7.5 plus 2 standard deviations 1.9. Okay, I get 11.3. So my standard deviation is 1.9. My maximum is 1.3. So anything above 11.3 would be considered unusual. So 10 then is not, because it's not greater than the max. Okay, so again, different scenarios, virtually the same procedures over and over and over again. Okay, so email me if you have any questions with these. Okay, but like I said, I think once you've done the first couple, you'll see how it's the same thing over and over and over again, and then you can go from there.